Hi and welcome to section 6, in which we are going to look at some aspects when it comes to working with application deployment in AWS. So we're going to go into our first video, which is the pros and cons of each technology, which we have seen in the previous videos. So first, let's look at the Elastic Load Balancer service. First is the pros, and just for a note, when I go on to each service, you're going to see a lot of pros for each service because all of these aspects really help you build a good architecture on the cloud. So when we look at the load balancer service, well, this allows you to add elasticity for your application. So we've seen earlier on how we could launch virtual servers and place them behind an elastic load balancer, and then the traffic gets distributed behind the load balancer for your virtual servers. So this is adding elasticity for your application. This service, the Elastic Load Balancer service, scales automatically based on demand. So if the number of users who are hitting your load balancer starts to increase, the service will automatically scale based on the demand. You don't need to do anything yourself. Also, there are different types of load balancer services. So you have the application load balancer and the network load balancer. These work on different protocols. So if you want to work purely on the TCP protocol where you just want fast distribution for your underlying request, then you can use the network load balancer. If you want to routing of the traffic based on URLs, you could use the application load balancer. And there are always continual improvements to the service like any other service in AWS. So AWS will take customer feedback and then will add features and improvements to the Elastic Load Balancer service. There is better availability for your application by spreading the Elastic Load Balancer nodes across multiple availability zones. And it also has integration with another service known as the Web Application Firewall. So this allows you to protect your web application from application level attacks. The only con I can think of right now is that with all other services in AWS is that you don't have control over how the load balancer service works. Sometimes from a security aspect, sometimes from a compliance aspect, companies want to have control over the service itself, and that's something you don't have with the Elastic Load Balancer service. But again, that goes with a lot of services on the cloud. Next, we come to autoscaling. So this allows you to add scalability for your application. So we've also seen a use case earlier. So if your demand increases on your underlying virtual servers, you can add it as part of an auto-scaling group. That group can scale based on demand. You can scale in and scale out based on your requirements. So if the traffic to your servers are increasing, you can scale out, and in order to reduce costs, when the traffic becomes less again, you can scale in. You can also use custom metrics for the scaling process. So you have inbuilt metrics such as CPU utilization in order to scale in and scale out. But you can use your own function level metrics for the scaling process as well. You can control the scaling process. So let's say you want to suspend scaling. Maybe you want to troubleshoot a virtual server. Now there's some cons. When you're using the scaling service, you have to monitor the scaling process because you are the one who is defining how the scaling will take place. Sometimes your application might scale for the wrong reasons. So you have to monitor this. But again, this is not a con for the service. This is something that you have to understand and monitor when it comes to scaling. Now let's look at the relational database service. A big pro, less maintenance overhead. You don't need to think about provisioning or maintaining the underlying servers which host your database service. You also have features such as multi-AZ, which allows the database to be more fault tolerant across multiple availability zones. And you can also have read replicas, which can allow you to distribute your read traffic onto other instances for the database itself. You can also scale your architecture whenever required. So let's say in the beginning you decide what should be the instance type to host your database. At a later point in time, if you feel this is not enough, you can scale the database or instance type accordingly. Now there's some cons. Again, you don't have control over the underlying database server. This is fully managed by AWS. Now obviously a pro to this is that AWS will manage the underlying patching, the security patching for the server. But again, if you are a company which needs full control, then you should think about maybe using the EC2 instance to support your database. You might also have another database such as MongoDB, which is not supported currently in the database service. So again, even though there is a good support for the majority of databases in the service, such as MySQL, Oracle, etc., if there is a database which your company is using, this might not be supported in the service. This is something that you have to cater to when designing your application. And then obviously, if you are using extra features such as multi-AZ and read replicas, understand that you have to pay more. Now again, these are not cons of the service, but these are more things that you have to think about when you are designing your application. Elastic Beanstalk, a big pro, again, less maintenance overhead. In our demo, we saw how quickly we could provision an environment using the Elastic Beanstalk service. A lot of resources were provisioned automatically by the service, and we got an application running in a matter of minutes. It has support for multiple technologies and platforms, and it also has support for Docker. You have the ability also to control parts of the environment itself. So let's say you want to change the underlying instance type which supports the environment, you can do that as well. There's some cons. The environment provisioning again is not under your control, and sometimes the provisioning itself can get delayed. Now I've seen this myself. Obviously the service is improving, is currently adding new features, but I've also seen this in forums. Sometimes the environment itself does not get provisioned and you have to terminate it and create a new one. Again, this depends on region to region, and this is something I just want to bring about when you're looking at the cons for the service. AWS Lambda Pro, you only pay for the running code, you don't need to maintain any servers, and it's good for hosting administrative code or scripts. We've seen this earlier on. Again, the only con, it does not have support for all the programming languages, even though all the popular ones are supported. Please note the supported programming language when you're designing your architecture on AWS Lambda. And like with any other service on the cloud, the only thing to note is that you don't have control over the underlying architecture. Now let's move on to our next video, which is the well-architected framework.